Good afternoon and welcome back to Shaper Sessions. Today we have a fun one, and one that we haven't done yet. We're going to take a ShaperHub project that we found that we liked a lot, and we are going to build it. And we're going to talk about the things that we liked, the things that we tweaked, and kind of go through my first experience building it. And by the end of it, we will be assembling a stool, a 24-inch three-legged stool by Doug Eltoft. Beautiful design, incredibly sturdy. A couple of really fun joints in this stool that caught our attention. One directly off of the top, we have a pretty unique seat design that takes three different sections, different direction of grain orientation, and brings them together in kind of a somewhat box joint fashion. Something I haven't seen before and I really liked. And then, of course, the three-way brace joint in the middle that brings it all together. So that's a little better view of the top. And if you joined us on our IG Live, I actually cut the last section and glued this up, but we'll talk a little bit about the snags that we hit too in just cutting this thick of hardwood, what kind of cutter we used to do it, and how it came together in the end. But I just want to quickly show a low-down shot of that joint as best I can. There you go. So that is a really cool joint that I haven't yet to see somebody do with Origin, and it was a pleasure to learn how to do, and I can't wait to apply it to more areas of my work. So let's talk about it.
While you're making a note there, Jake, we'll get Ted to upload the link to the community project so that people can follow along and look at the instructions, sync it with their Origin, and be ready to go.
Yes. That would be great. Okay. Just a quick recap on the stool top. It's an optional portion of the project. You could just say glue up two boards, cut a circle, and the mortises in it. This three-sectioned bit is an optional part, which again I tried it because I really liked it and I'm happy with how it came out. A couple things I ran into. I decided to use a very long 1/4-inch cutter. It's actually the cutter that we recommend using for the StockShare Premium project. So it's got 1.5 inches of cutting flute length. So with that great length comes great responsibility. You're going to be biting off a lot of wood when you're doing your finish passes. So one of the things that I found was kind of biting at me when I was doing my finish passes and my negative offsets to get it all to fit together is when I came up into these corners, these 90-degree turns, it was loading the bit up so much that I would actually feel Origin kind of jump. It would go from having just one surface of the bit contacting material to now two sides of the bit in the corner, and I would feel that. And it wasn't giving me the cut results that I liked. So what I did instead, I did my rough depth passes. Then I came back in with my 0 offset and I just plunged directly over each corner. That gave me a little bit of room to breathe once I came back through and did my finish pass at 0 and didn't bind me up in those corners. Then after that, I came in on each piece and did a negative 0.004 of an inch offset just so that they all came together. I knew what to do on all this because Doug went into great lengths on his instruction list, and it's part of the project that you can download, print out. As you know, us as the people that put together premium projects, we appreciate a well-documented project. So something like this makes us very happy, and part of the reason why we chose it to dive into today. So in his project description, he recommends couple areas where I diverged from his instructions. He recommends getting a 1-inch cutting flute length. It's a 1/4-inch bit with a inch of cutting flute length, and he's really smart about how he does his depth passes and offsets to be able to get a clean finish pass. Still, even though the material itself is 1.25 inches and 1.5 inches, you can still do that with an inch bit. It is a similar tactic that was used in Noah's tri-stool. this is an exaggerated version, obviously, but with the stock 3/4 length of cut bit that comes with Origin, you can cut a tenon that'll fit into an 1.5" piece of material just by getting creative with how you step in different layers or using your offsets, and in combination with depth passes to get to your final desired results. I chose to use the long cutter, what I call Excalibur, mostly because it's enormous and gold. But that came with its own trade-offs, like I said. Yeah, I'll show it down here. If for anyone that has done the shop stool project, you know that this is great when you need it, but not something you want to use all the time. Main reason being, it's still only a 1/4 inch, and it's so long that things that happen over length and at speed, and when you're loading the tool up, you get different vibrational frequencies that come through. You'll see chatter. So funny things happen over length with anything spinning that fast. So just something to be aware of. Go into it slowly, and sneak up on your final offsets and get that desired cut finish.
Just add a quick one, yeah. With a cutter like that, always try to get a cutter that's only as long as you need. If it's longer, it's just introducing more flexibility and chatter and issues, as Jake mentioned. But yeah, this is a particular project where the full length is required.
Yeah. And the glue up process was actually kind of fun. Again, doing it live is always a trick. On IG Live, I got it all together. I put one band clamp around it. I'm cranking down on the band clamp. I'm tapping these with a rubber mallet to make everything kind of loosen up. And one final tap on the side, it all just came perfectly together. There was a little bit of dishing after it had dried, after the glue had dried, so we had to sand that flat. But I still think it was absolutely worth it. It came out beautiful, and it's gonna, especially in this ash, it's gonna really pop once you put some finish on it.
What do you think would help with that, Jake? You put a strap around it, right, and cranked it and hit it with a hammer?
Yeah.
How would you keep it flat?
I think working on the doing your glue up on the corner of your workbench and using some hold down clamps to keep that flat against your, provided your workbench is flat, as well as the band clamps. I think that's in hindsight, I would have gone back and done that. Thankfully, we have a thickness sander and it came out really nicely, so I'm not too mad at myself about it. Yes, but the one thing to consider is if it were for whatever reason to be too severe, part of the project is you already cut the mortises here. So as that glues, if it's kind of dished up, that angle on that mortise is going to be ever so slightly off. And most places you'll see it down right here where the tenon comes in. Something to be aware of. Anyways, so doing the whole stool again, doing it in cherry this time. I've gone through and I've cut 2 parts of every single part, and I'm going to walk you through the 4 main cuts in this project, starting with the 3-way corner brace. So it's such an incredible joint. What I ran into is my own chisel skills, which weren't that fantastic, and this joint requires you it cuts a radius, and you have to chisel that corner joint to match an acute point coming into it. One thing that I really ran into is I was using standard chisels, which I'll show down here, don't have a very steep bevel. Sorry about that, a little technical difficulty. How about now? Okay, if you want to come down here to the tabletop, I'll just show your standard chisel with the bevel it's not significantly sharp, or the bevel isn't that steep. To get into a very sharp area that is needed, I was running into the edge of this chisel. So what I really needed, and didn't have at the time, was a dovetail chisel. Far steeper there, and would have allowed me to get into that tight, acute area without marring the sides.
And that's that corner in the center, right, Jake, where they all come together, the three the braces.
Yes, I'll just show that again briefly. Right here, right where these pieces come together. So you have you're left initially with the tool radius, which is using a 1/4 inch bit. It's going to give you roughly eighth inch radius. Chiseling that out, again, it's 3/4 of an inch deep. Keeping that straight, I found a little difficult. Again, that kind of is more of a reflection of my chisel skills. So I wanted to play with the design. We wanted to figure out a way to incorporate that corner radius. Did a couple tests in ply, and pretty happy with how it came out. And I'm okay with rounded corners. So that is what I'm going to do on this version. We're just going to test out. We're going to see how it looks in hardwood. I've already cut these 2 mating parts here. And I'm ready for the third. So, over the workstation, we got a lot of cutting to get through today, so I'll try to hustle through it without leaving out any details. I have already cut the first half of this. He's very specific. Doug is very specific on all your reference faces. In fact, he even has you make specific jigs for workstation and highlighting the versatility of workstation in a really wonderful way. This particular jig over here goes over the left side reference pins and extends that reference face all the way up to the top surface of workstation, which the angle guide that comes with workstation comes close, but it's actually intentionally set down below. But because we are referencing off an angled piece, we need that top surface all the way at the top to press up lightly against. Now I can rotate and cut my other side by just referencing there. So I'm going to go ahead and set that up.
I'll get Ted the info for the aligning information and dimensions of all those pins, so you can make your own fixtures for workstation.
Oh yes.
It makes it a sort of a kit bashing thing. All the key dimensions are laid out, and you can then do whatever you want.
Yeah, I'll just briefly show the 10 degree jig that he has that you will be using on the mortises. on the tenons. Slips directly over the workstation pins, puts the screw through the middle, and that holds that 10 degree for your tenons. Okay, crank my clamps down. Give the old feel check, nice and flat, and we're good to go. I have already set up a 1/4 inch grid per Doug's instructions. What I found interesting on his file layout in this particular part is he uses, if you could show my screen, there you go. Right down here in the bottom left side of the file is a guide triangle, or is a guide square that you're intentionally setting 1/4 of an inch out. That allows this file to be slightly larger than your material, and so you can clear all that material away, and it trims the material down to its final length. Just thought that was a very creative and handy way to do things. I'm gonna go ahead and clear my cut history. Do this in 3 passes. And also this allows you to start with a pocket because it extends past my material. I can just hog out all that material. So I'll run through that real quick.
So these ones you want to be really careful about the depth you go to. Obviously we're going to get to the exactly halfway depth here. And you'll see pocketing's a breeze here at 1/4 of an inch, the same as you always would. So even though we're using a long bit, we're only at 1/4 of an inch at the moment. Jake's being careful in those corners so he doesn't bump around and cut into the material he wants to keep, you'll notice that the pocketing operation keeps a little border around the cut, but you never get the final dimension you're looking for when you're pocketing. You'll see the difference between the blue area and that black line is showing you exactly what's protected whilst pocketing, because it's kind of a free-form cut. We don't expect to get clean edges at this stage. The key there is to follow up with a finishing pass or an inside cut where you would perform a finishing pass. So because Jake indexed at the far end, he can now cut here and know that he's creating the correct length detail for this whole support bracket. And I believe this one, Noah and him were working on it. You'll see he's rounded those corners. So now there's no post operation with the chisel. He can just mate these three elements together, and he's good to go. So this is just the top half of the joint, obviously. This can then be flipped and do the same operation on the bottom side. And what you'll get there is the two elements that then sort of scissor together over top of one another. Well, three when you combine all of them. So now you'll see he's moved over to the inside cut. So this is where he's cutting to the final dimension. One note, there is currently an offset active. So you'll see the little white line there. The toolpath's automatically moved away from the material. And that's going to protect his cut. Now you notice these areas that weren't partially cleared by the blue pocketing operation. In those corners, there's actually quite a lot of material. So be very cautious as you approach those sharp corners, because you go from effectively a finishing pass to a fully loaded cut. So see how you hear that little chirp sound in the corners there? That's when the cut is suddenly loaded up more than it would have been otherwise. And then he's just going to round this corner. You'll notice you're cutting completely new material there. Yeah, so that can catch you out, especially if you've done a lot of depths as a pocketing operation or with an offset, and then suddenly try to do a finishing pass. Those sharp corners are now, there's a very large amount of material to remove because it's the full depth, even though you think you're just doing a very light finishing pass. But this is a great way to, fixture up an element and rapidly cut some pretty elaborate joinery into it.
All right, we're good to go.
So what was your final offset there, Jake?
That was a -0.003 of an inch, and I put that on all three so that it gives a little room for them to come together. I don't want to cut them line to line. I need a little bit of wiggle room there, and room for glue.
And then you've already cut the opposite sides, and now we're looking at the final operation for this whole piece,
exactly.
Or this end of the piece.
Yes.
And did you double check your depths there so that they didn't overlap or not quite meet?
I had done these. I did the other three right before we started this, so I was confident that it wouldn't. But yes, having a pair of digital calipers right next to you is always a good idea. Just make sure that one, your depth is correct, you Z-touch correctly, and that your material is in this case exactly 1.5 inches by 1.5 inches.
Nice stock preparation, Jake. Dialed.
Okay. Worth bringing over here just to get a nice visual fit. And I'm quite happy with that. That's going to come together beautifully. Now let's go ahead and cut that back tenon.
So you can see the other ones, he's already cut the tenon, and it's at an interesting angle there. You might say, oh, just drop a domino in. But if you did it at a 10-degree angle, you'd have to be quite careful. Do you want to show that, Jake?
Yeah, down here.
So you can see there, A, it's long. B, if you were to put a domino down that low, it would probably punch out the back before you got enough engagement for it to hold strongly.
Yeah.
Yeah, no, it's a pretty interesting one. And it's a full through tenon, so you actually see it on the other side. Did you have any insights from that, Jake?
Yeah, and I'm going to talk a little bit about it. I wanted to, when I first cut my tenons, they were a little short, so it required a lot of sanding to make them flush. So I'm going to just do it a hair deeper, just 0.01 deeper, just so that they either come totally to the surface or just slightly above. That's going to make it a lot easier to flush trim with a pole saw or just sand flat. Okay, support bar back in there. Getting my angle right.
So that support bar gets you the consistent indexing height now. So you've got your left-hand side locked to 10 degrees by the little fixture you made there. And then the support bar means that everything is at the same height.
Yes.
So that's why you're able to do these 3 back-to-back and get solid, consistent outcomes. And then what's your approach to clamping those, Jake?
For these guys, I am just making sure that I have even clamp pressure across. I want to always put 2 clamps because I don't want anything to twist. And I'm using
some people try to clamp both sides, right? And others make sure top and bottom, but make sure they're dead center.
Yes.
You just keep an eye and make sure it's not torquing as the pressure gets loaded up on it.
Exactly. As I twist here, it may pull away, so I'm just keeping a close eye on the height and the fact that it's set here. And I'm happy with that. Give it the old wiggle test. We're good. Next thing I want to dial in is my spoil board. Use those cam clamps just to snug it up. I'm not trying to put any undue pressure, just enough to snug it up to help with any potential chip out. And swap my cutter.
You're going from the big long 1.5 inch one, Jake. What are you swapping to here?
I actually had our standard 1/4 inch cutter, 1/4 inch, 3/4 inch long cutter in there because I was only cutting, in this particular instance, 3/4 of an inch deep. So
that's a great point. There's no point in having a really long cutter in if you don't intend to be using the entirety of its flute length.
Right. And I want these to be dead on, so right now I'm just throwing the engraving bit in backwards to use as a probe to set up my grid. Sure. Give you guys a better view. All right, there we go. Do a new scan. Get a nice clean image of the top of my brace. And we're going to create a 1/4 inch grid. I love the sound that Origin makes when it's diving the bit down to be used as a probe. Boom. And on this left probe, be careful not to press too hard because you are pushing into an angle. You don't want to dent the angle. You just want to lightly tap, lightly put pressure against the outside to get that nice clean 0, 0 on the bottom left corner. There we go. I'm grabbing the brace tenon. Now you'll notice I'm placing it at a negative 1/4 inch, negative 1/4 inch. That's again to give me room on the outside to clear all that material away. And the tenon is actually considerably offset. You can see that's the edge of my material right there. And the tenon, as we go deeper, because it's at an angle, is going to expose the proper amount of tenon, just like so. Oops. Now we can throw Excalibur in there. And for the sake of speed, and also because I'm cutting into end grain, and I have felt how it's going to react to this bit in this particular scenario, I'm going to be doing 1/2 inch depth passes to get down to a total depth of 1.5 inches. Then I will gently work my way in. It's a different feeling when you're cutting into end grain because of the way the grain is directed. It cuts off nice little curls versus cutting into cross grain where you're fighting against end grain. All right. You may have also noticed that I choked up on the spindle just a little bit because if I put the spindle all the way down, the bit would be resting on my material, and I don't want that to happen. So I'm just pulling slightly up and then tightening my spindle carriage. And Z-touch. All right. 1/2 inch depth passes. I'm going to pocket all this away, then change it to an inside cut, and bring my tenon to its final shape.
So let's check if my audio is the right level. Apparently it's been clipping a bit. Can you hear me? Okay, so we can see a little bit from the underside here, and also Jake's screen up there. So you can see he's actually taking a fair amount off with this cutter, and he's got his foil board in there. So that means he's not going to cut into any metal parts of his workstation. So this is really getting the job done quickly here with this long cutter. And yeah, as he mentioned, he's tested it before. Works great in this wood softness. Like if it was, say, hickory or something like that, you'd probably want to tone down how deep you're cutting with one pass. But yeah, this is a great way. He's just clearing out his that pocket that Doug made. And you saw the grid operation meant he could precisely align that exactly where he needed it. So it's actually pretty quick once you get up and going. Now, next pass, still pocketing. So you'll see he's leaving material around that geometry, the actual tenon he ultimately wants to leave protruding. And keep in mind, this is all at 10 degrees. It's a little bit difficult to see here, but you know, this is the type of thing that would be pretty annoying to set up in most other traditional means. And Origin's, especially with workstations, very flexible for just getting this quickly hooked up and cutting exactly as you wish. I think one of the modifications Jake mentioned he was interested in trying out was leaving a little more tenon exposed, just so he could then come and trim that off with a pull saw or something at the end. So it's always wise to build in means of taking care of any tolerance issues with any woodworking process. Like for instance, if we didn't clamp that top surface enough, it would end up with the, what's that, sorry? Yeah. Just making sure he doesn't cut his clamp with huge long pockets like this. You got to keep an eye on those sorts of things. Thankfully, it's all set up in a way that he can undo one, nudge it down, and then clear that out of the way, keep him safe.
Excellent catch.
It's the under workstation view.
I mean, it would have just been the rubber of the cap. We would have been fine.
Yeah, it is covered in a little rubber protective shield, so you're not directly into aluminium. There's a bit of a buffer there, mostly to protect the wood. It's not designed for cutting into. So now I believe he's at his full depth here, so it's quite an interesting view to see what goes on underneath Origin. We don't expect to see any flex in that cutter. It's soft wood, but you can detect it by the shrill sounds you hear Origin makes. If it sounds really kind of wretched, that means it's loaded up. If it's doing that screeching sound, that means the cutter is under load and is vibrating a little bit. So just pay attention to all the sounds you hear while you're cutting. Some of them are just the nature of cutting with a high-speed cutter. Others you want to be mindful of and stay on top of if they can be addressed, if they're warning you that there's a loose collet or something like that.
Now I'm going to come back in and start taking that to its final shape using offsets.
So that was all pocketing, right, Jake?
That was all
That's
pocketing.
Just freeform paint by numbers.
Yes, and now you can see I have a nice tight path around my tenon that I'm going to follow.
So now he's doing full length. This is where the 1.5 inch cutting flute length is going to be fully engaged, and he's moving around, leaving a small offset. So the ultimate goal is to have the final pass be all but unloaded, and you just move around smoothly, and you clear out exactly the material you need and get the final dimension you're after. The good news with Workstation, you can actually put this back in here if you did a test fit and it didn't quite fit, because we can re-index exactly where it was and it hasn't moved relative to the tape. We could come through and take another 1,000th of an inch off if we wanted to and adjust the fit. So there's no need to get too bold with how much you take away in terms of offsets that make your part smaller, given that you can come back and trim some more off if it's too tight. So that first up path was just taking care of the buffer left by pocket. Now this pass, you can't actually see the value he's entered there, but it'll be something like negative 3,000th of an inch. So that'll be a sort of glue gap, and just make sure it's effortless to assemble this tenon.
Yeah, exactly. Negative 3 thou. And that's also because I'm going to dry assemble this at the end, and I want to be able to get it back apart. In the first ash stool that I made, I followed along with the recommended offsets, and it fit fantastically, but there was no way I was getting back apart. So for this purpose, I want to be able to dry fit it and take it back apart. But there we go. That is one of our tenons. Now our center triangular joist is all ready to go. Let's run on to the legs. We have a tenon and a mortise on the leg. Same 10-degree fixture on Workstation. This one's only going to 1.25 inches deep because the top is slightly thinner. But same process, except it's a square tenon versus more of a long oval tenon like the brace. But you're going to work your way out with a pocket, come to the inside, use your offsets to dial that fit in. And yeah, then we're going to move to the mortise after that. Same deal, support bar onto Workstation. Kind of realign my clamps here.
Did you say that was still at 10 degrees, Jake?
This is still at 10 degrees, yeah. It really is an amazing, like how this tool comes together, it filled me with joy when I was doing the final glue up and just watching it all squeeze together. Given the angles and the very specific lengths that things need to be, it's a very impressive project. Alright, just double checking that my clamp is not too high. We're ready to go. Gonna do a new scan here. And if I were doing, in the instance of doing multiple stools, I would save each one of these workspaces and rename them just to make my life a whole lot easier when I'm coming back to cut the same thing. Say I need to do this leg tenon over again. I can just hop back to the workspace that I've very clearly labeled 3-legged stool leg or three-legged stool mortise or tenon.
Yeah, it's a great tip for getting things consistent or coming back to a project midway through or repeating it again later. Yeah, naming workspaces is hugely helpful.
Yeah.
You can also duplicate them if you want to adjust something and keep your old one without any concern of doing harm to it by deleting something or anything like that. So here Jake's doing the gridding operations. So he's touching on both sides. We might be able to see the cutter down there. Not quite. So he's just touching it against the edge, and that's going to define the x-axis, and then against the right edge to define the y-axis. It's super flexible. You can probe any corner, top, bottom, left, right. And there's a shortcut for anyone who just wants to kick off a project with a grid that will place one right at the center of where the cutter currently is if you just double-click the green button. That's if you're doing circles where you don't care what orientation they are or something.
Okay, so same thing, gonna run through at half-inch depths and work my offsets into a final tenon size. Put this back on.
So I'll walk you through what Doug has done with some of these. I mean, I think Jake mentioned it a little bit at the beginning. His offsets were pretty pronounced for his first few passes. He'd do 0.05 inches for his offset. So that's leaving a lot of material. It means if you were to just then do a finishing pass, there would still be a lot of material to cut. So it wouldn't really be a finishing pass. But what it does get you is the ability to move quite quickly for if you're doing several passes. Because there's that 0.05 inch buffer, if you were to deviate a little from your intended path, it's unlikely to cut into your precious material at the final dimension. So then the pro move to make it work is then to step down to like a 0.01 inch cut prior to doing your sort of tolerance pass. So at 0.01 inches, that's more in the realm of a regular roughing pass. So then the final pass will not be loading up the cutter and you'll get a very nice, accurate cut. At the moment, we are pocketing. So what I'm talking about here is the offsets you use for the final inside cut, which may be a little confusing because what we're doing here is technically the outside of a tenon. But what Doug's defined here is the shape that he wants to pocket out, just to make it easy. You could literally just make the shape of the tenon and do an outside cut, but then you would end up doing a lot of sort of strange offsets to clear out all this material. He's gone to the effort of making a pocket, which is just a gray shape with a hole in it, and that means that we can then quickly clear away just the material we need surrounding the tenon we want to keep. So yeah, then you'll see Jake will go through and do his own version of this stepped offset down to his final dimension, which will be like negative 0.003 inches or something like that. So that'll get him his glue gap and his final dry fit tolerance he's looking for. So now that we see an actual dotted line there, we're now following a toolpath. So this is his inside cut where he's working through the tolerance, the offsets to go to his final pass of negative 0.003, I believe. Sorry, I can't see his actual settings there. You'll be able to see better than me probably. But just in case anyone's unfamiliar with using Origin, that's what's going on there. And one thing that's also worth noting is these rounded corners actually make it easier to operate Origin quickly. So not only does it mean your inside and your outside of your tenon doesn't require any chisel work. Like if that was a sharp corner, you would have to then go in and chisel it. Because it's the radius is bigger than the radius of the cutter, it can come off Origin and then immediately be dry fit. But it also, I find that radiuses on corners make it very quick to cut. Rounding the corners less jarring if it eases its way around a curve.
All right. There we go. At that 10-degree angle, it's ready to go straight into our seat. Beautiful. Let's do the mortise, and then we're so close to assembling. The mortise brings in the, let me get this ready. It brings in the shelf. So we're going to use a little double-sided tape to hold that down, and I'm also going to go back to that original fixture for workstations.
Jake's going to be using the regular shelf here. I'll send you up a link of some alternatives. People in the community, we have been making alternative shelf designs for fixturing various projects. So much like the clamping face fixturing ShaperHub project I mentioned, there's also a few alternatives for shelves and things. So I'll get them up to you now.
And do a little changeover on workstation's clamping face. I'm going to bring it up to the top level because I'm not cutting outside of my material width. I'm just cutting inside of it, so I don't have to worry about using a spoil board or anything. Yeah. And I'm going to scoot this out. That's going to get in the way. Okay. And because I'm doing a longer piece, I'm going to need to remove one of my support arms that holds up the support bar. So it's nice to be able to, if I'm doing something that exceeds the size of workstation, I can kind of take pieces off that get in my way as I see fit. Slide this into position.
So that's the regular stock shelf that ships with workstation.
Yep.
Looking pristine, Jake. Is that one you cut yourself or brand new?
It's just brand new. And I am actually going to use the angle fence for this particular part because the one that we have to make for the other cuts goes a little too high in this instance and doesn't allow me to use the shelf. So I want to have a reference face, so I'm going to pop that on, and it still allows me to slide the shelf down on there.
Yeah, it's worth noting. So the shelf isn't like a hard indexing left and right object, if that makes sense.
Yes.
So it's in these little channels, but there's a little bit of play left and right. So that's why Jake's got that little fixture, the angle fence there. He can then confidently bring it up to a consistent height and then push his stock hard left, and it'll index vertically against that pin. It's not using the shelf for its left and right index.
Bring that up. Making sure we're flush with the top surface of workstation. Clamp into place. Whoops. Double it with a little visual inspection.
Just got to check the underside of that, Jake.
Yeah. And we're good. Nice and flat. 2 pieces of double-sided tape just to make sure it doesn't go anywhere. Now, we're cutting all the way through, so the height is, we're going to go slightly above 1.5 inches. Material is 1.5 inches, so we're going to set that to about 1.51. So we cut all the way through.
And that MDF surface we're looking at on the shelf there is designed to be cut into. It's a spoil board. We also ship the files to create your own. I will send that up as well.
And worth noting that the double-sided tape is something that we also sell on our store. I live by this stuff. It works fantastic. To set this, I just pressed against my my angle fence as well as against workstation, and just evenly put pressure down, and put a little extra pressure just to make sure that the double-sided tape sets. Okay, set that to the side. One more scan.
I think there's a little note here saying the adding the tape after managing the height means it could come up a little proud, but as we're cutting the whole way through, that's a non-issue. But yeah, you would often put your tape on double-sided tape on the bottom first, then bring it up flush.
Yes, thank you. Setting up my grid.
This is the same process, using the cutter to identify the edge of the stock. Origin knows where it is relative to the tape field, which we see here as the surface of the workstation, so we don't even need to worry about tape here. Just scan and then lower the cutter. Now he's confident his cutter's touching against the side of his stock underneath there, and then he gets updated on screen. He's created an X, now he's creating a Y just by touching the edge. Quick note, if you hold down and then move to the side for the third press, the cutter remains low until you release. So if you've got a really delicate surface or stock that you want to protect, keep that button pressed as you move away, and then it'll retract once you release the button.
That's a really great point, especially on this bottom corner where it is delicate. That would be the perfect opportunity to use that feature. All right, back into design. Right there, our leg mortise. Following along Doug's instructions, he said grab it by the middle left anchor point and move up the leg from the bottom to 8 inches. 8 inches and 0.75 inches. So that gives us a centered mortise. And this is just an inside cut. So we're going to do this because we're going into cross grain in appropriate depth passes. All the way through with an offset. So I'm going to go through this.
Jake's cutting this one, pretty straightforward. You've seen the others, and you'll notice the auto button change color when he presses it. So that's when Origin's moving on its own. He's not coaxing it along there. So you notice as he rounds the corners, he's holding down firmly on the handles and then pressing the auto button and letting Origin zip around those corners for him. So that's using the little mini gantry to take care of that precision. Otherwise, if the cutter's loaded and there's a lot of resisting forces and they're suddenly sort of changing, sweeping through like 180 degrees, it can get pretty squirrely. So it's just a lot more stable and simple to just hold Origin still, hit the auto button, let it take care of that detail for you, and you get much cleaner outcomes. So you can see he's just stepping through the passes, making good progress here, and we're at a 0.02 offset. So this is a pretty modest roughing pass. It's usually between 0.01, 0.02 most people settle on. What's cool about this little slot is the cutter is under or exactly twice its diameter. So going down one side and back the other side, you clear the whole thing back out. You don't leave a little piece of material in the middle. So I often end up, designing projects with my cutters in mind, because if I had to do a whole pocketing operation prior to this, it would add time to the actual creating and assembly of the project. So now he's doing his finishing pass. We're at 0 offset. You'll see that the difference between the roughing pass and the finishing pass. It's tempting to go fast for a finishing pass, but the key is, that's the final perfect cut quality is all done with the finishing pass, or pretty much, unless you really blow a roughing pass. So you want to make sure that you move smoothly, and much like Jake here, you see here he's moving more cautiously as he takes that final offset off to get him his glue gap. So even though it's easy to move, you're not resisting much, that's what gets you your final quality. So there you have a finishing pass. Does it go pop, Jake?
It is going to have a pop. Oh, there's dust in the back. That's why I wasn't seating. All right. Pull off my double-sided tape. That extra 0.01 was perfect. It just gave me just enough to when I glue up, after everything's glued up, I can take either a flush trim saw to flush up that tenon to the outside of my leg, or even just a sander and just lay into it.
And worth mentioning there, if you're operating a cutter beyond its flute, like its documented flute depth, you end up scuffing ever so slightly at the top of the cut. So there's no longer cutting there. So you have to A, make sure you've cleared out all the material, otherwise it's just going to collide with it. And B, know that it is ever so slightly scuffing against that surface, because there's no longer ground sharp edges.
Yes. And you'll even see burn marks, or you'll feel a lot of resistance while you're cutting that if you're not actually engaging any cutting flutes. We're ready to assemble. Let's do it.
Nice one, Jake. Let's do it.
Let's do it. Okay. It is a tricky one to assemble. So I will, first and foremost, in the instructions, he recommends gluing the braces into the legs first, letting that set up. It's going to make your life a lot easier when it kind of comes together. But for this, in this case, I'm dry fitting everything, so just going to balance it all in my hands. Yeah, and just a reminder, I intentionally oversized everything by a couple thou, just so that I could dry fit it together here now and take it back apart in the end. Yeah, in any other instance, I would want to keep my tolerance is really tight, especially for a through tenon. I want to leave a little room for glue, but I'm also really focused on that fit over time and wear and use. Oh, it's just falling right into place. And I put that one on the wrong way.
Thankfully you didn't glue it, Jake.
Exactly. Always dry fit. It's like measure twice, cut once. This is where the tricky part comes in.
Then you get your whole family together to hold things.
Yes. Bear with me here, people. I want to see it come together as much as you. Stay there. There it is. That was the trick, just getting that try together. Now my tenons are all lined up, and look at that, just slid into place. Flip that over. Voila.
Nice. 24 inches high.
24 inches high.
And then there was some other things we wanted to look at. He had a lathing operation that was actually really cool, the way he fixtured that, right?
Turning operation, but yes. I really wish that we had a lathe that could turn this large of a diameter, because I absolutely would do that. But he dished out the seat on a lathe with a fixture that you can also cut with origin. So you take the seat, you cut the fixture out of plywood or MDF. It has those tenons that stick out, and you can just mount the seat to that and turn on the lathe, give it a nice dish. I'm really happy with how it looks flat. Maybe since I have two of them, I'll play with using a shaping tool on like an Arbortex shaping tool on an angle grinder. I don't know, but one's going to stay flat. One might have like a little tractor seat shape to it. But either way, I'm very happy with how it came out. It's a fantastic project. As far as the center chisel point, if you love chisels and you pride yourself on how to get that exactly sharp, all the more to you. We're going to also share the rounded corner option with Doug, and if he wants to put it on the project, he absolutely can. But this has been a very fun build. This is kind of my favorite part about ShaperHub and the community, is that we can share ideas, share projects, build on them together, make them more user and origin friendly, and just elevate all of our work.
Looks great, Jake, and thanks, Doug. That's really epic. You went
you really did
a great deal of effort to make that pleasant for everyone picking it up and giving it a go.
Right on. Thank you, everyone, for joining. We are out.